Hello, everyone. Thank you for joining. Today, we're going to be talking about etcd watchers not working, how we can improve the error handling in your applications. So, today's agenda, we'll be talking about what the etcd watchers are, how they're used, how we can perform locking on key directories when using watchers, how you can monitor your etcd watchers to make sure that they're running, and how to cache the data that you're using from etcd locally on your applications. So etcd is a key value storage system. So you can kind of think about it as a Python dictionary. So for your key, you could have like a restaurant, and then for your value, you can have like a pizza place, or you can have a phone number, a address, XYZ. For the watchers, these pay attention to these specific keys and or directories, and it triggers an action. So say we have for the example I just gave for restaurants, we change the value to, instead of it saying Pizza Hut, we change it to Domino's. So you'll see that once that change happens to the etcd database and you have a watcher running, you'll get a notification that the value was changed, and then you can trigger an action as needed. So for this example here, we have stocks, and I'm using the dictionary, so it just kind of creates like a hierarchy here. So we have the slash stock slash foo. So the kind of like the convention that I'm using here is the stocks would just represent what I'm meaning at a high level, and then for the foo, it'll be the individual stocks that we're interested in. So for this example, I'm using foo as the key, and then for the value, I'm designating it as the stock price. So we have four different times here. So time zero, we're adding a key value here to the database, and we haven't set up the watcher yet. At time one, you can see that we're setting up the watchers to sell. So that's the action that I'm defining at 120. At time two, we we see that the foo stock has increased to 130, and that's reflected in the database now. The watcher gets this notification, but because we're not trying to do any action, if it increases, then we don't have to worry about it. There's no action needed. At T3, once we see that the price has changed to 120, then the watcher will get a notification, and then we'll trigger an action. And in this case, we can just say for simplicity that we're going to trigger, to sell the stock in whatever portfolio you're using, whether it's Robinhood or Fidelity. So with watchers and with changing data, we'll have to make sure that we take care of the race conditions to make sure that our data is not corrupted. And we can do that by using the lock API. So here, I want you guys to consider the situation since we've been talking about stocks. So going by step here. So the foo will change from 120 to 119, and we have our watcher defined to where we sell if the price gets lower than 120, and we buy more if the foo is greater than 115. So for step two here, we see the watch program would trigger, the sell since it's lower than 120, and then a new value for the stock has gone to 110 by a user to the database, and you can see here that there's a race condition happening between these two. So, and to prevent that, we want to make sure that once the watcher gets the notification that the foo has gone below 120, we lock that specific key, and once we finish our action, then we release it, and then the user can change the value to 110, and then we can trigger and watch for the second action, which would be to buy more, right? Buy more once the foo is at 115. So this will prevent the race condition from occurring and make sure your data is not corrupted. For monitoring watchers, so we had to make sure that our watchers were up and that they received the notifications, that nowhere in between the connection was dropped. So a way that can happen, right, is if there's like network connectivity issues, you'll see that if you send new values to the database, the watcher will not pick them up. So that's why we have to monitor them and make sure that we just reestablish new connections for the watchers as needed. So here, a way to monitor that is, so I described the hierarchy here with the slash stock slash foo. So what we use in this case would be slash stock slash health, and then we can define a interval on how often we want to ping to make sure that these watchers are up and running. Usually, if you have one watcher running, that's a good signal that the other watchers are running as well. So you just want to make sure you're setting up that your program to send the to change the value of the health in an interval, and then set up your watcher to acknowledge that we do have established connection with that CD database and the watchers are up and running. So for more complex software, I'll use cloud here as an example. So it could be the case that there's a key that's changing constantly um, from different places, and I'll give an example as cloud, right? So in cloud, there's different instances. There's subnets, load balancers, storage. So all of these could be changing one key, and the way that we can kind of try to minimize the downtime is to have a copy of your etcd value stored locally, and once you have that established, then once the connection comes back up, or your program, your applications reestablish that connection with the watchers that you have defined, then you can just push the code that you've cached locally and push it up so your database is up to date, and it minimizes downtime, and it makes sure that that you can come back up faster. So with that being said, thank you guys.